Okay, now we're going to describe reactions more thoroughly, more completely, more than just the equation you've been using. There's three types of chemical equations that we are going to explore in this chapter. The first one is called molecular. This is exactly what you've been doing. You did molecular all through chapter 7. Molecular is what we've been addressing all along. It shows everything. It shows reactants. It shows products. It shows all the chemical formulas. It shows all states of matter. And it is balanced. That is a molecular equation, so this isn't anything new at all. What is new is what we do with that molecular. The first thing that we do is we write a complete ionic equation. The point behind a complete ionic equation is that it shows us exactly what's going on in the chemistry. I mean, it shows everything. So we show all the reactants and products as they really exist. Take, for example, let's do sodium chloride. You know that if you take sodium chloride and you put it in water, it's going to dissociate into sodium ions and chlorine ions. So an aqueous solution would really look like how I've written the products. Now, this is a physical change, that's true. But a complete ionic is going to show everything that is an ion as an ion. It still shows all states of matter, and it is balanced. To write a complete ionic equation, we have to start with the molecular equation. And then we're going to show all the ions as they really exist in the solution. So we need to take a look at this species first. So I'm going to change my pen color. So here we have sodium, and there's 2 sodium ions. And we know that this guy, when it breaks apart, Na2SO4, it's going to break apart into 2 sodium ions and 1 sulfate ion. So this is what we really need to write. AQ plus SO4, 2 minus AQ plus. Now we're going to do that same thing for this one. There's 1 lead ion, so Pb, 2 plus, plus, and there's one of these. No, there's not. There's 2 of those. 2 NO3 negative. Now, for those of you who might be stuck on how I got the 2 positive charge for the lead nitrate, well, you can take the lead nitrate off to the side, PbNO3 2. We know that this compound has to add up to 0. Nitrate has a -1 charge, so 2 times -1 is -2, which meant lead had to be a +2 charge. Okay, now we're ready to power forward. Sodium nitrate. Well, I've got 2 sodiums. And this one kids will miss a lot. They will miss that there are 2 nitrates, so watch for that. I missed AQ, and I should have an AQ here and an AQ here, plus. Now, notice that that is a solid. That means in solution, it does not exist as ions. So we leave it alone. Ag2SO4 solid. Ladies and gentlemen, that is a complete ionic equation. Don't forget, it has to stay balanced. Now the last type of equation this video covers is a net ionic equation. And this one shows only those species who actually play chemistry games. It shows what actual chemistry is happening. It will show all states of matter, and it does need to be balanced. To do the net ionic equation, the first thing you need to do is start with your complete ionic equation. And you need to ask yourself, who in the net actually played the chemistry games? Well, the chemistry game in this one was the formation of this guy. So we only care about that. Who went into making lead 2 sulfate? Well, we know it was the lead, and we know it's the sulfate. And the net ionic equation is only going to show those 3 species. Those are the only things that played chemistry games. Well, you have to start with the cation because it's always better to be positive. So Pb2+, and that should be aqueous, as that should have been as well, plus SO4, 2 negative, and that one's also aqueous. And that's going to yield our product, PbSO4 solid. Ladies and gentlemen, you are done with the net. Don't forget to include all states of matter and make sure it's balanced. So for this one, we need to write all 3 types of equations. And really, the only 2 pieces of information I need are those 2 pieces of information. So we're going to start this by writing the formula for sodium chloride. Well, we know sodium is a +1 and chloride is a -1, so we end up with sodium chloride plus silver nitrate. Silver is a +1, nitrate is a -1. So, plus silver nitrate, and that's going to yield, well, we know sodium dumped chlorine, so now it's going to hook up with nitrate, and that leaves silver to hook up with chlorine. This one started aqueous, the directions said so, and now you have to decide which one of these. If you use your solubility rules, you know that the silver chloride is your solid. Is it balanced? Yep, indeedy. Now we're ready to write the complete ionic equation. So this one breaks apart into ions, so we have sodium plus chlorine. This one breaks apart into the ions, silver plus nitrate. Now we're going to have to go over here. Since this one's aqueous, we're going to break it apart into sodium ions plus nitrate ions, because that's how it exists in solution, but leave the solid alone, because that's how it really exists. Now I'm going to go through and put in my AQ, because it's easier this way. And now you're ready to write the net. Remember, the net is the only one that plays chemistry games. So I like to start with the solid. Who made the solid? Silver and chlorine. And it's better to write positives first because it's better to be positive. So we have silver plus chlorine yields silver chloride. And you are done. Let's try this next one. You go ahead and read through all of that, pause the video, and give it a try. So potassium hydroxide and iron 3 nitrate. So let's start with the molecular equation. So potassium hydroxide, and that's aqueous, as the directions said so, and iron 3 nitrate, that's also aqueous. And we're going to swap the anions, so we end up with potassium nitrate plus iron hydroxide. Well, according to the solubility rules, that one is your solid and that one's aqueous. So now we just need to balance it. So we have 3 hydroxides here. I'm going to need 3 potassiums here, 3 nitrates. Good, we're done. We're now ready for the complete ionic equation. So in this one, we're going to break everything apart into ions. We have 3 potassium ions. And don't forget, that means 3 hydroxides as well. 1 iron ion, and that had a charge of +3, see? +3. Plus 3 nitrates. And that's going to yield 3 potassium ions plus, oh, better put AQ in there, 3 nitrate ions. Watch that. That's one most kids will miss. They'll forget that that 3 applies to both. I ran out of room. Plus, and you want to keep the iron hydroxide together because it is the solid. That's another one kids will miss. They'll want to break that apart. Don't do it. It's a solid. So for the net ionic equation, then, the only thing you want is who went into playing the chemistry games. Well, that was the iron and the hydroxide. So we just basically can bring these down. We have 1 iron ion plus 3 hydroxide ions, aqueous, and that's going to yield iron hydroxide, like that. And you are done. All right, one more that I want you to do. I want you to do this one on your own, and I do want to see the work tomorrow in class. So give this one a try. These next ones are, of course, extra credit. So have at these, and I'll take a look at these tomorrow. Up next, we're going to look at acid-base reactions.